Hello, for my second problem of week 4A, I chose problem number 8, and it says at a certain location, the horizontal component of the Earth's magnetic field is 2.6 times 10 to the negative 5 T, which is Tesla, due north. A proton moves eastward with just the right speed so that the magnetic force on it balances its weight. Find the speed of the proton. So my image demonstrates that it says the magnetic field is due north, so our magnetic field is going north. And then a proton moves eastward with just the right speed so that the magnetic force on it balances its weight. Find the speed of the proton. So that means our proton is moving to the right, which does make sense with our rules of protons moving. So also, just to go over this first, F is force, and which is a vector that measures magnitude and direction. Magnetic force, which this in particular is magnetic force, which is on a moving charge particles. SI units is newtons, which is N, and then M is mass, a measure of weight, and SI units is kilograms. And then A is acceleration, a vector, which is a vector that measures the particle's charge of velocity due to time. Its SI units is meters per second squared. I have the meters over seconds written out here. And then V is velocity. Its SI units is meters per second. It's a vector that demonstrates how fast the particle itself is moving. And then B is magnetic field. It is a vector that demonstrates the strength and direction of a magnetic field. Its SI units is Tesla, T. And then Q is a value of point charge. Its SI units is coulombs, which is C. So for this problem, I knew that I needed to use my magnetic force equation because it is asking us to find velocity. So this equation has velocity in it. It has our force, it has our B, our magnetic field, and then also I'm given, in order to find this, I have to, well, first of all, force is equal to mass times acceleration. So I have to just plug in force into this. And then I plug in this whole thing for force, for my force equals mass times acceleration equation. And then so it's QVB times sine theta equals mass times acceleration. And then I simplify this. I divide by Q, B, and sine theta over mass times acceleration to get velocity by itself. So velocity equals mass times acceleration, which is over QB sine theta. So for this equation, I knew that I had to do this because I know I'm given acceleration because of gravity, because it says we are on the Earth's magnetic field. And in the previous problem, it told us to ignore it, but in this one, we don't. So I know the mass of a proton, just in general, you can looking that up, and then that is 1.67 times 10 to the negative 27 kilograms. And then the charge of a proton is consistent. It is 1.6 times 10 to the negative 19 coulombs. And that will be our Q then for later. And which is our point charge, which was stated earlier. So then now I just plug everything into this formula. And it is velocity equals our mass, which is 1.67 times 10 to the negative 27 kilograms, times 9.8 meters per second squared, which is our acceleration, which is our gravity. That's how we know that. And then all divided by our Q, which would be 1.60 times 10 to the negative 19 coulombs, times 2.6 times 10 to the negative 5 Teslas. That's moving upward, north. And then times our sine theta. And then we know it's 90 degrees because it's perpendicular. Well, you can see in this drawing I did. Our magnetic field is going up, and then our proton is going to the right. It's going east. So we know that our angle is going to be 90, so that just cancels out to become 1. So then I simplified this I multiplied this out and got 1.6 times 10 to the negative 26 on top, divided by 4.16 times 10 to the negative 24 on the bottom, to be able to get a velocity of 0.00394 meters per second. So that means that this is the V, the velocity right here. So we know it's going to the right, it's going east at a velocity of this amount right here. And so just to say again, this is our proton, it's moving east, and then gravity is acting down on it, which is what I have here, and then our magnetic field is going upward. So that's how I got my angle, was these two.